Okay, we're on the homework on the equation part, and we're going to be doing this. We'll be doing problem number 1, number 2, number 3, number 4, number 5. Number 5 comes with a picture, and we'll talk about that and why you'd want to draw a picture and why accurate pictures are nice to have if they're given to you. We'll do number 6. Number 6 also comes with a picture. We'll do number 7. Comes with a picture. Number 8, number 9. Wow, a lot of questions, huh? So I'm going to go through them all. It might be tough for you, but we'll do it. And I'll do it at the whiteboard. All right, so we're going to go back. And I'm going to share another screen with you. But again, we'll be starting with problem number 1. So let me do a new share. And let me do a share here, okay? So give me 1 second. And I'll put down problem number 1. Again, I want to tell you we're in section 4 of the notes. We're in the homework. And this is divided into 3 parts. We did simplifications, we did identities. Now we're doing equations. They're all related, by the way. Equations are going to have conditional solutions, and we're looking for them. So in problem number 1, and again, you should have the notes in front of you at this point. It says, how many solutions are there for the equation? I'll write it down for you. 3 cosine 2x equals minus 3. Then they say the x is between 0 and 2 pi. Again, it's touching the 0. It's not touching the 2 pi. What I would recommend you do is just graph 2 things out. Graph y equals 3 cosine 2x. Yes, we spent time in graphing. I'll call this the first graph. And the other graph I want to put down is y equals minus 3, right? Let me do this one first. And, beginning of it, really kind of simple. That's when 2x equals 0. That means x equals 0. And the end of this, right, fairly simple. It's when 2x equals 2 pi, or x equals pi. All right, let me draw the picture. I think I'm getting pretty good at this because we just spent a lot of time doing it, right? And what would you get? Well, at 0, again, we're doing y1 now. Maybe I'll put this in blue. You would get the number, let's see, we'd get 3, right? All right, and kind of move it along. And I want to move up to, pi. And at pi, I'll put pi over here. That would give me 3 again. That was pretty simple. All right, and then I kind of, divide it up, and not that it has to be terribly accurate, but the 4 equal parts. And this would look like this over here. What would that be? That would be, let's see, pi over 4, right? Not that I need to list that, but I get minus 3 over here. And then I get 0 there. I'm going to draw my little cosine curve in over here. Again, there's really no need for doing accurate pictures, other than the fact that it's nice to have a picture you can rely upon. Let me keep going. And I'm going to go to 2 pi, right? And again, the length of this thing's pi, so 2 pi, just a repetition. Someone says, why am I doing that? I'm looking at this. So I'm going to draw that picture in. I'm going to reproduce the cycle of this thing. It looks like this over here. It does not touch 2 pi, though. Put an open circle there. Now I'm going to graph the second curve in, and I'm going to put that in green. That's the blue is y1, right? So this is the graph of y1. And in green, I'm going to put y2 down. What does it say? 3. So what does y equal 3 look like? It looks like this. All right. The question is, how many times did it hit the curve? So this is how many solutions are there? If I look at it, there's one here. It hit there, and it hit here. So I'm going to claim there's 2 solutions to the problem. All right, let me write that down for you. So there's 2 solutions. If someone said, what are the solutions? I would say x equals 0. That's on that interval. And the other one is x equals pi. I realize some students want to say 2 pi. 2 pi is not included. It's got to be numbers between 0 and pi. So number one is done. And look at the answer key, and it does clearly state there's two solutions over there. I'm going to do number two now. And number two says find all the solutions. All right, so let's write this down. This is tangent squared x equals 1. Now it says find all the solutions on the interval between 0 and 2 pi. All right. So what I'm going to do here is just simply say the tangent, because remember I need to get a value for this. So I'm going to say tangent could either be plus or minus root 1. Our recommendation is to draw a curve. This is between minus pi over 2 and pi over 2. This is one cycle. Doesn't have to be accurate, by the way. That's the tangent function. And now put down the line. And again, I graphed out. Let me write that down for you. I graph y equals tangent of x. And I'm also going to graph out y equals plus or minus 1. Well, that's two numbers. So it looks like this. That's y equals 1. And it looks like this. And that's y equals minus 1. So I noticed two places. There's one here and one there. They should be relatively simple to do. And the first one is between 0 and pi over 2. And I'm going to say, what number would that be? Well, what number, the tangent of what number would give you 1 would be pi over 4. Let me write that down for you. Now, of course, the tangent function repeats itself on this cycle length over here. And what's that cycle length? It's actually, if you look at the distance, it's just pi. So I'm going to write that down now. So it's going to be pi k. With the understanding k is some integer, like 0, 1, 2, minus 1, minus 2. Let's put the next one down. And that's going to be what? X equals. Well, it's between minus pi and 0, and that's going to be minus pi over 4. It also repeats itself on a cycle length of pi. All right, I'm going to write these down now. And you certainly, when I'm doing these things over here, I want to get the common denominator because it makes it easier for me to do. And what's that going to be? Pi plus 4 pi k. What's the other one going to be? X equals minus pi plus 4 pi k. By the way, I only want the answers that are between 0 and 2 pi. Could be no negative numbers. So I'm going to look at the first x. I want to point out what I mean by that. I'm looking at this guy over here, and I'm going to pick the simplest number here for me that would keep this thing positive. So I'm going to say 0. What would you get pi over 4? I'm going to start to write these down for you. Again, not saying this is the answer. What's the next one going to be? I'm going to pick k to be 1. Now, I'm using this over here. If I took k to be 1, what would I get? I would get pi plus 4 pi, which would be 5 pi over 4. Now, by the way, you keep on going. Certainly if I did 2, what would I get? I'd get 9 pi over 4. And, I could keep going. What are they doing? They're going up by 4. 1, 5, 9, 13 pi over 4. But the thing is, I had to realize I have to really stop at 2 pi. And what's 2 pi? It's 8 pi over 4. So these are no good. They're too much. All right? But it does go on forever. And all those numbers go on forever. They're just too big for the 2 pi number. Let's do the next one. All right? And I want to point out what I'm doing over here. I haven't written the answer down yet. I'm looking at this guy. And let's write those down. Now, if I chose 0, I'd have a negative number. I can't do that because there are numbers between 0 and 2 pi. So I'm going to choose 1. And what would you get? Minus 1 plus 4, which is 3 pi over 4. We have an answer key to look at later. All right. I'm going to go, 0 was no good. I'm going to get a negative number. I just did 1. Now I'm going to do 2. And what's that going to give you? 7 pi. Because minus 1 plus 8 is 7 pi. And these are going up again by 4, 3, 7. You get 11, right? And then board would be 15. And this goes on forever. But my deal about this one, I'd be really careful. It says it has to be between 0 and 2 pi. And 2 pi is really going to be 8 pi over 4. So these would be no good. They're too big. So now I think I know my answers. I'm going to write them down for you. And I'm going to write them down in order. So it's going to be pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. I say it's a lot to students. I make mistakes all the time, and sometimes I'm just not paying attention, but I'm going to look at my answer key. And when I do that, I want to emphasize, I want you to look at the answer key as well. And let's go through it. I'm seeing the pi over 4. I'm seeing the 3 pi over 4. I'm seeing the 5 pi over 4 and 7 pi over 4. All right, let me go to number 3. And let's see. And I'll write it down for you. Again, I'm going to find all the solutions between 0 and 2 pi. So I know my x's are between 0 and 2 pi. And what do I see? Secant of x times the cosecant of x equals 2 cosecant of x. All right. So what are you going to do with this? And certainly I'm looking at it, I'm wondering, how could I solve that? You really have to stop saying to yourself, and I'll tell you why. It's got to be easy. We're not giving you things you can't do. What I would recommend is setting it equal to 0 and then factoring it to see if it makes any sense. All right, let me factor out the cosecant, all right? We left off with secant all right. It's going to take some wisdom here, I guess. And if you've done the graphing homework, and if you've done, I hope you realize that I'm looking at this thing as a product. The product equals 0. And I'm wondering, are these things here ever equal to 0? Well, if you've done your homework with the graphing and the cosecant, you're going to realize this is never equal to 0. It's never 0. But then the big question is, I wonder if this is equal to 0. I'm going to write that down for you. And what do you see? Secant x minus 2 equals 0. Well, I'm going to go through my basic patterns to do the problem. I like to get these things as the function equals a number. I don't like secant, so I'm going to write as cosine. And what's cosine going to be? 1/2. It's a reciprocal of that. What am I recommending? Well, what we recommend in class to do is we recommend to draw a picture of this. So a picture of what? The cosine. Put this one over here. Pretty easy to do. That's a cosine curve between 0 and 2 pi. And this number over here, you can use degrees if you want, by the way. I think I can do them right. This would be pi over 2. And this would be 3 pi over 2. All right, so that's a cosine curve graphed. All right, now what we're going to do is graph the line 1/2. I want to point out this is 1. This would be 1/2. I trace over, hits it here. Trace over, hits it here. All right. So someone said, where did it hit? Certainly between 0 and pi over 2. Somewhere there. I may not know where it is, but I know it hit there. And between 3 pi over 2 and 2 pi. Now, some students would prefer to use decimal. I'm not decimals, but the degrees. So that would be 0 degrees or 90 degrees. So I know my first answer is between 0 and 90 degrees. We'll look for it later. What's the next one going to be? Between 270 degrees and 360 degrees. All right. What am I going to do? Reference triangles. I'm trying to figure out the reference angle. And what's a cosine going to be? Well, the angle x, use my right triangle for a reference. Whoops, that's not a very good picture. Let's go back up a little bit. You should become very familiar to you. This is going to be the x, and this would be root 3. Do I recognize the angle? Yes, the reference. The reference is going to be 60 degrees. All right. So if it's between 0 and 90 and the reference is 6 degrees, this angle here would have to be 60 degrees. All right, now you're between 270 and 360. So what you're doing is getting the reference of 60. So you're backing away from 360, 60 degrees. So this angle here would be 300 degrees. Now I want to repeat, we can't use that because they spoke in radian. So I want to make sure you understand what I'm going to do now. I'm going to convert this to radian measure. So I'm going to write that down for you. And this would be pi over 180 degrees. And what would that be? Pi over 3. Look at the key later. Now I hope you realize that 300 is 5 times that number. So it'd be 5 pi over 3. I put this down in the box. I want to recommend looking at the answer key now to see if you can agree with that. And I'm seeing the pi over 3, and I'm seeing the 5 pi over 3. I go to number 4. And number 4 is really, it almost appears to be the same question over and over again, slightly different results though. So number 4, what do we get? Sine squared x plus cosine x plus 1 equals 0. Well, I had a couple of problems. I know the x here has got to be on that interval from 0 to 2 pi. 2 pi is not being included. So someone says, what are you going to do here? And what I'd like to do is be able to solve an equation. And this equation over here, it's got sines and cosines in it. I'm going to try to write it in one variable. I'm sorry, one trigonometric function. And I'm going to rewrite the sine function as 1 minus cosine squared plus cosine x plus 1 equals 0. I'm going to keep rewriting it. And this would be minus cosine squared x plus cosine x. And 1 plus 1 is 2, right? I can multiply both sides by minus 1 because I don't like the negative coefficient in the square term. I'm going to make some attempt to factor it. And that's going to be cosine. Well, it's going to work with finger numbers. Got to be 2 and 1, right? And it looks like this over here. Let's take a look. Cosine x plus 1, cosine x minus 2. Well, you get cosine squared. That's good. Minus 2 plus 1 is minus 1 cosine x. That's good. Yeah, looks good. So then the question comes is, does the cosine x, this was in the zero product rule, by the way, ever equal minus 1? And the other one would, for the zero product rule to go through with this, does this ever equal 2? I hope you realize that if I just drew the picture of the cosine curve, looks like this over here, the number 2 is just never going to hit that number. This would be y equals 2. But if I wrote down minus 1, what would I get? I get this. And it hits it 1 time. And this is y equals minus 1. Where did it hit? Right at pi. So I think I put my answers down. There's only one answer. And what's the answer? That answer is pi. All right, let me look at the key. And this is number 4. And I clearly see that in the key. It says x equals pi. All right, so I'm going to do number 5 now. And just give me one moment. Okay. And number 5, I'm going to use the picture they have there for you. So why would you use that picture? You don't have to. All right. But what's their question? Their question is, can you solve something? It's number 5. Let me push this on the side. I'll pull it back later. This is y equals. I'm sorry, it's not y equals. I'm misreading. Let me just erase that. It's cosine x equals root 3 over 2. I want to point out, this is solve for x. It says nothing about it being restricted on an interval. So my first goal over here would just be to draw the picture of cosine. And I can get better at that, right? So I'll put something like this over here. I'm going to use degree measure. This is 0. This would be 360. And that's one cycle of it. This would be, let's see, 90 degrees, this would be 180 degrees, and this would be 270 degrees. All right, so that's just the cosine curve. Then what I'm going to do, root 3 over 2. And what's root 3 over 2? Yeah, roughly speaking, it's about, I'm going to say about 0.9. So I'm going to draw a picture, and this is 1 up here. So 0.9 is over here somewhere. It's there. Hits here. Someone says, where does it hit? Between 0 and 90, and then it hits again between 270 and 360. So my goal over here is to emphasize that, I want to figure out what the angle is. And how do I do that? By drawing a reference triangle. And what's a reference triangle going to be? It's going to look like this. All right. So, 2 root 3, because the cosine of x, right? This would be 1 over here. And what's x? This is the reference. The reference would be 30 degrees. All right. So I know between 0 and 90 degrees, the angle would be 30 degrees. However, this trigonometric function, the cosine curve, has a period of 360 degrees. K, where K is an integer. I'll write that down later when I box the answer. Let's do the next one. And the next one is a number between 270 degrees and 360 degrees with the reference being 30. So I back away 30 from 360, which would be 330 degrees plus 360 degree K, where K is any integer. All right, I'll put a box on that. I'll look at the answers later. I want to also write down the radian measure. I want to point out when I'm doing these pictures over here, I'm going to write down, the points of intersection here, and there. I'm going to write these numbers down here. This is 90 degrees. This is 180 degrees. This is 270 degrees. And this is 360 degrees over here. It's really the same story. What picture is better? The one the machine does. All right. But the pictures are provided for you for a reason, by the way. Help get you guys, encourage you. There's also a line there. And I want to emphasize over here, they're telling you what the graphs are. They got them both down for you. All right. Let me put down the radian measure. We'll check the key later. And radian measure, I'll write this over here. Let me write this down, 30 degrees times pi over 180 degrees. What would that give you? Pi over 6. You should know that 360 degrees is 2 pi. X equals, well, 330 is 11 times 30. So it's 11 pi over 6 plus 2 pi k. Put a box on this. And I'm going to look at the answer key. All right, now when I'm looking at the answer key, I'm trying to say which one do they have written down. The radian one, which they should. So x equals pi over 6, just 2 pi. They're using n instead of k, by the way, but I go back and forth between the two. But k, again, is any integer, and n is also any integer if you want. And what's the next one going to be? 11 pi plus 2 pi k, or in that case, what they're writing down is 2 pi n. Again, n would be any integer. I'm using k for any integer. All right, let me keep going. And I guess what I'm going to do is number 6 now. And let's take a look at that. I think I might have that one down for you. Yep, I got a picture of it. I want to point out what I mean by that. I see the picture over here. I'm still going to, I know there's a picture there, but I'm still going to go through the work. And this is number 6. And this is the tangent of x equals -1. So what do? I want to point out what I would do is just draw a picture of one cycle of the tangent. And it looks sort of like this over here. All right. This is minus 90 degrees and 90 degrees. And then I'm going to say the ratio of -1 will be over here somewhere. And this would be y equals -1. All right. Does it intersect? Yeah, one time. That's it. And then you should know the reference triangle for that is a 45, 45, 90. So I would get x equals minus 45 degrees. I want to point out that why that is. I'm between minus 90 and 0. Plus, what's the length of that curve? Right, the cycle length. Well, it's 180 degrees. I'm going to use n this time, where n is an integer. All right. Now, by the way, there's something disturbing. I'm not saying it's wrong about it. I'm just saying something disturbing about it. And I'll tell you why. We tend not to like to use negative numbers if we can resort to a better number. All right. So I'm also going to write down by just simply moving forward 1. All right. So what would you get? Like if you move forward 1, like you put n to be 1 and not 0, you would get minus 45 degrees plus 180, which would be 135 degrees plus 180 degrees n, where n is again an integer. So this one looks better to me, but I still want to write the radian measure down for you. All right, so I'm going to put this one over here. I want to point out 135, I'll put this down for you, times pi over 180 degrees. I'm converting it. If you can do this in your head, fine. Do it in your head. Don't have to write it down. This would be what? 3 pi over 4. I'll write this down. 3 pi over 4. And you should know that 180 degrees is pi. Again, the understanding is n is an integer. All right, let's look at the answer key. Look at the good curve they've given you. And I want to see if I got it right, because I make mistakes sometimes. Oh, they do good. They're good. So let me just look at the picture. I want to put what the picture is. The picture is a tangent function. And again, I actually kind of like my picture better because it was easier for me to answer that. But looking at over here, I do see there's points of intersection. There's an infinite number of them. All right. Now I'm just drawing a partial graph of it. All right. Again, the graphs that are being provided to you may be helpful. They may not be helpful. Let's go to the next one, which would be problem number 7. All right. So I'm going to do number 7. And let me see if I can do that for you. And I'll write down for you. Number 7. And what's number 7? It's secant x plus 2 equals 0. Boy, this is deja vu, isn't it? And you would get secant x. Remember, we want to get a trigonometric function equals to a number, minus 2. And I don't like secant, so I'm going to write as cosine of x equals minus 1/2. But what I do, I would draw the picture of the cosine curve, which looks like this over here. And again, I hope you realize I'm not drawing the most accurate picture, but it's probably good enough for me. Most students are much more familiar with degree measure, and so therefore it might be a good idea to put this down. All right, so I'm going to put minus half down. What is it? This is minus 1. 1/2 over here. Hits there. Okay, so what do I have to do here? Reference triangle. All right. I want to point out before I do that, though, the first hit is between 90 and 180 degrees, and the second hit is between 180 degrees and 270. Now here comes the question. What's the reference triangle? Well, I know the ratio is 1/2. I'll put this down for you. This is reference now. Oh, x reference is 60 degrees. We'll go to radian later, by the way. So my question now is I'm between 90 and 180, but the reference is 60. So I'm at 180, I back off 60. That would give me 120 degrees. It keeps hitting itself repetitively on a cycle length of 360 degrees n. Before I was using k, now I'm using n, where n is an integer. All right. What's the next one going to be? The next one's going to be between 180 and 270. So I'm at 180 and I'm going to move forward 60 degrees, which would put me at 240 degrees plus 360 degrees n. All right. Where the understanding is n is any integer at all. All right. By the way, the picture on the side is a good picture that certainly you can look at. You're not going to read the answers from the picture, but you get an idea that it hits it twice there. Let me put down the radian measure for you. I'll write this over here. And I'm going to put 60 degrees down. It's something you probably should start to comprehend. Pi over 180 degrees. Whoops. And that'll be pi over 3. Well, what's 120? It's 2 of those, right? So it's going to be 2 pi over 3. You should know that 360 is 2 pi. Now, 240 is 4 times 60. So it's going to be 4 pi over 3 plus 2 pi n. Again, where n is some integer value. I'll write that down for you. What's an integer? 0, 1, -1, 2, -2, so forth and so on. So let's look at the answer key and see if they have that written down. Well, I'm seeing the 2 pi over 3 plus 2 pi n. I'm seeing 4 pi over 3 plus 2 pi n. Fairly simple. The graph can be used as an aid. I typically put my own kludgy little graphs down just to help me out with the picture. All right, so what I'm going to do, go to the next one. And let me see if I got the next one for you. And I guess, what number did I just do? Got to remind myself here. I can't remember. Oh, I'm going to go to number 8 now. I'll write that down for you. And I got to get to 8, right? Oh, yeah. It says solve for x. 3 cotangent squared x minus 1 equals 0. Well, my goal is to get a single trigonometric function equals to a number. And let's go through that. So 3 cotangent equals 1. And then I'd say cotangent squared equals 1/3. I don't like cotangent. I'd like to get in terms of sines, cosines, or tangent. I can do that tangent, right? So it'll be tangent squared x. This is going to be reciprocal now, which would be 3. Tangent x would equal mu square root rule plus or minus the square root of 3. So what I'm going to do is, what I've always done is just simply draw a picture of the tangent function. And it looks like this. That's a tangent function, one cycle. And I'm doing plus or minus root 3. So I'm going to say, that's root 3 over here. Minus root 3, I'm sorry. And this is root 3 up here. So I know it hits it, right? And someone says, I wonder what those numbers are. Well, this is minus 90 degrees. This is 0 degrees. That's 90 degrees. I'm going to do my reference triangles. I hope it's going to be easy. Pretty typical they are, by the way. So the tangent is root 3 over 1. It's going to be the reference. This is 2. I recognize this immediately. So the reference is 60 degrees. So what again? X equals, well, between 0 and 90, a reference of 60 would be 60. What's the length of a tangent function? 180 degrees. Let's put the next one down. Well, the next one's between minus 90 and 0, and its reference again is 60. So that'll be minus 60 degrees plus 180 degrees K. Let me repeat this. For some reason, and I'm not sure why, I don't mind it, but they don't like to use that minus 60 degrees. So they move up one. So when they move up one, what do they say? X equals. Well, that would be, if you move up one, it'd be 180 degrees times 1, which would be 180. And 180 plus or minus 60 is 120 degrees. Plus 180 degrees K. I'm going to write the answer down for you now. There's 2 answers. So X equals 60 degrees plus 180 degrees K. The other answer is X equals 120 degrees plus 180 degrees K. Understanding K is some integer value. Put a box on this. I'm going to put the radian down for you. X equals, I'm getting a little better at this. 60 degrees times pi over 180 degrees is pi over 3. I recognize 180 to be pi. Now 120 is 2 of those, so it's 2 pi over 3 plus pi k. Again, the understanding is k, or n, is an integer value. Okay, let's look at the answer key. And I always kind of wonder, do I get the right answers? I make mistakes. Let's take a look at it. Pi over 3 plus pi k. They're using n again. 2 pi over 3 plus pi k. We're doing pretty good. Let's go to number 9. And what's number 9? It says solve the equation. I'll write it down for you. And these should not be difficult questions. And it's factored it has an equal to zero product rule. So the big question is the sine of x ever equal to -2? And I hope you realize the sine function looks like this over here, and -2 would be down here. It never hits it. All right, so this doesn't have a solution. This is no good. Let's put the next one down. The next one, does the cosine of x ever equal -1? Well, I'm going to draw a picture of the cosine curve, and it looks like this over here. The question is, does it ever equal -1? If you trace over, it hits it there. Now, where is that number? At 180 degrees. So I'm going to write this down. And what would it be? X equals 180 degrees. It repeats itself every 360 degrees. I'm going to put n down with the understanding n is an integer. I'm going to put the radian measure down. X equals pi plus 2 pi n. And I'm going to write n is an integer. All right, let's see how we did. And I'm looking at it, and I noticed they wrote down, pi plus 2 pi n. I feel good about that. It's the right answer. All right, let's go to number 10. And there's 2 more to go, 10 and 11. And again, I'm hoping at some point you've already done these things, or after you watch me, you're going to do them to yourself. It's so important you start to study. You don't want to be left behind, particularly with your educations. It's just too precious to leave an education behind. This one looks bizarre. So number 10 is what? Sine squared x minus cosine squared x equals 0. All right. So, my question is, how would you do this one over here? I would say what I would do, there's many ways to do it, but I would convert everything into one function. And so I'm going to convert everything into sines. Now the cosine squared is 1 minus sine squared x equals 0. All right. All right, let's keep going. Now what do you see over here? I guess you'd get 2 sine squared, right? Minus 1 equals 0. Well, my objective is to get a trigonometric function equals a number. And what do I get? 2 sine squared equals 1. And I'm going to divide both sides by 2. Looks pretty simple, doesn't it? You get 1 over 2. And the sine would equal, I'm using the square root method you learn in Math 100, plus or minus 1 over the square root of 2. What would I do? I would draw the picture of the sine function. I'll put that down for you. And 1 over root 2 looks sort of like this. And minus 1 over 2 looks sort of like this. It's hitting 4 times. 1, 2, 3, 4. The first one's between 0 and 90 degrees. The next one's between 90 and 180 degrees. The next one's between 180 degrees and 270 degrees. The next one's between 270 and 360 degrees. Question is, what's the reference? The reference has to be 45 degrees. Look at it. It's 1 over root 2. So I'll write these down for you. I'm going to say, just looking at that interval, 45 degrees would be that first one. The next one's between 90 and 180 with a reference of 45. So 180 back off 45, where would you be? 135 degrees. What's the next one going to be? Well, it's between 180 and 270. So if you're at 180, you move forward 45 degrees, that would be 225 degrees. What's the next one going to be? It's not bad. The next one, if you look at it, what's it going to be? It's 360 back away 45 would be 315 degrees, right? All right. So if you want to write them down in radian measures, pi over 4, 3 pi over 4, 5 pi over 4. Let's see if I'm doing that right. Yeah, and then 7 pi over 4. All right. A bunch of answers there. It keeps repeating itself. I want to get, I'm somewhere. Is there a general statement I can make on this one over here? That's not going to be so complicated I have to write down a bunch of things. Well, this goes up what? 90 degrees, doesn't it? And if I did this thing, that would be up 90 degrees, wouldn't it? And if I did this one over here, well, 225 plus 90, it's still 90 degrees up. So I think I'm ready to write this one down. what's it going to be? X equals 45 degrees plus 90 degrees N. I'm going to write the radian measure down for this. X equals pi over 4 plus pi over 2 N, with the understanding that N is an integer. Okay, look at my key. I noticed on my key I just wrote down 4 answers. I didn't write a general statement down. So I'm just going to circle this over here. And it's pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Looks pretty good. All right, looks pretty good. By the way, if you look at those answers, they're going up by pi over 2. And if you looked at that, they're like 2 pi over 4. They're going up by. Okay, same thing. Let me look at number 11. And number 11. And number 11, what is number 11? Oops, go back to black ink. Sine 3x equals 1/2. No, we're not trying to confuse you. X is between 0 and 2 pi. All right, I'm going to graph it out. Y equals sine of 3x. All right. So, I'm kind of looking at it, and I'm going to make it simpler for me. I'm going to say y equals, and what I'm going to do is I'm going to let u, this is a trick, by the way. Okay, I'm going to graph this instead. Y equals sine of u. And what would you get over there? Pretty simple. It would look like, the sine curve looks like this, doesn't it? And I want to put out, this is u, and this is y over here. And what am I looking for? A half. Hits it twice. What's the reference angle there for sine? Well, I guess it would look like this over here, right? 1, 2, root 3. And the reference, I'll just write down u, reference. I'm talking u now. Would be 30 degrees, right? All right, I'm ready to write this down. So someone says, I wonder where it hit between 0 and 90. So the first u would be 30 degrees plus, well, it keeps repeating itself, right? Every 2 pi, we're 360 degrees N. All right, let's do the next one. The next one is going to be, let's see, it's between 90 and 180. So I'm at 180 back off 30. It's 150, right? Plus 360 degrees N. Someone says, you didn't want u, you wanted x. Well, what's u? It's 3x. So I'm going to take my little eraser out, and where I saw the u over here, I put 3x down for you. I'm going to take this, I'm going to solve for x. X would be 10 degrees plus 120 degrees N. I'm dividing both sides by 3. X is equal to 50 degrees plus 120 degrees N. Now someone says they didn't even ask for that, and they didn't. I'm not going to put a box in that. They asked for the numbers that are between 0 degrees and 360 degrees. I'm going to start writing them down. All right, let's do the 10 first. All right, what would you get? 10 degrees, right? And what's the next one going to be? Well, if I take n to be, I took n to be 0 to get 10 degrees. That would be 130 degrees, right? What's the next one going to be? 2. That's 240 plus 10 is 250 degrees. So I did 0, I did 1, I did 2. If I did 3, I'm out of the ballpark. It's 360 plus 10, which is 370. Let's do the other one. That would be 50 degrees, then 170 degrees. And next one would be 240 plus 50, which is 290 degrees. All right. So someone says, I wonder what their question is. We'd like you to read it. It says, how many distinct solutions does the equation have? 6. I'm counting them up. They're over here. 1, 2, 3, 4, 5, 6. 6 solutions. Okay. All right. I'm going to go to Sage briefly. And the reason I want to do that, I want to encourage you to try to use Sage as well. All right. So let me just do another share with you. And I'm going to open up Sage. I realize some students can install software on their computers. They might be using a Chromebook, or they just may not have the technical skills to install software. Not everyone does. If you're going into a STEM-related career, though, I would recommend that you learn how to use software. All right. Now, I'm going to go to sagemath.org. And for those students that can't use a terminal application, I want to point out what I did. I went to sagemath.org. That's the URL right there. All right. If you click on the CoCalc, this is CoCalc over here. CoCalc will launch. Of course, you might have to register an account to use this. All right. Welcome to CoCalc. What I want to do here is I want to do a new file. Whoops, sorry about that. And I want to make a Sage worksheet. Remember, you're going to type in commands like 1 + 1. If you hit the return key, nothing's going to happen. What do you have to do? Shift return for it to do something. All right. If you don't want to install software, this will be the easiest way for you to do this. I'm going to close this out because I want to go through the terminal application with you. All right. Now, someone says, why do you want to use a terminal? The reason I want to use a terminal is I want to, understand that it's good to have things running on your computer because you're not depending on someone else's computer to do the computation. So what I want to do is I just want to type in what I'm seeing over here. Reset. What does reset do? It kind of clears the memory out of any prior problems I might have running. X is a variable. You don't have to do that, but it's a good idea to get in the habit of defining variables. Now, what I mean by this, Sage already by default has X as a variable. And again, I want to point out, I'm going to start to maybe do something copy paste. Now, a lot of code is copy pasted. Now, the question is, what is this doing here? I want to tell you what it's doing. It's saying, is the sign of X identical to the opposite of the sign of minus X? Right? Now, by the way, sometimes what happens to Sage is it needs to launch, this application, and sometimes it takes a little while to do it. But once it's launched, it's going to be fine. But it comes back to be true. Do we know that identity? Of course we do. All right, let's put this one down. We've covered these identities already. True. We knew that one too. It's a co-function identity. By the one above it is an even odd identity. Let's see this one over here. I don't know what it's going to do, but I'll type it in. It's nice if you can read these things. I'm looking at it. It looks like, it's going to do something. I'm not sure what's going to do, but it's cosine pi over 6 squared plus the sine of pi over 6 squared. Let's see what happens. Ooh, look at that. It did arithmetic for me. And the real fact is we could have done arithmetic, and we've done that in the past, by the way. All right, let's put the next one down. This is a Boolean. A Boolean returns either true or false. I'm just going, oh, true. What do we say over there? It looks like an identity. We've kind of solved these things before. Now, you notice I'm always saying that these may be conditionally true. This one's saying it's true. By the way, true for all acceptable values for X's. There's a lot of X values that are not accepted in that problem over there. They're not defined. You get the idea. You can go through those Booleans if you like. Let's see how it does with solving an equation now. Wow, it solved it. By the way, it only returned one solution to it. All right. And that's a problem. All right. Let's do this one over here. This is a plot. I'm just doing copy paste because I don't want to, waste your time by typing in front of you. You should type though. And part of typing it'll learn. What does it want to do? Plot. Whoops, I lost the screen there. Give me 1 second. It wants to plot, cosine X. It wants to plot the line, -1 over square root of 2 between -6 and 6 for the X and between minus 1.1 and 1.1 for the y. What am I saying? Oh, something we've done in class, by the way. That's the graph of the cosine curve over here and the graph of the line y equals, I got to remind myself, minus 1 over the square root of 2. Now, how many times did it hit? 6 times there, and that graph over there. All right, let's put this last one line down over here. Just want to copy paste. And you get 2 answers on that one over there. All right, I think you get the idea. All right, I'm going to call it quits there. We're done with that homework section.